Good morning. Am I audible?
Good morning,
Yes, sir.
Okay. While we wait for the other students to join, is there any question regarding the assignment given yesterday?
Yes, sir.
Yes.
सर ते ब्रॅकेट आहे ना तो सॉल्व करताना खूप प्रॉब्लेम येते ते YN चे कॅल्क्युलेट करायचे Q इज इक्वल टू AV आणि मॅनिंगचा फॉर्म्युला घेऊन त्यामध्ये आन्सर मध्ये खूप आमचं डिफरन्स येते म्हणजे काल आपण जे लेक्चर मध्ये सॉल्व केलं ना त्याच्यानंतर आम्ही ते पुन्हा एकदा जेव्हा ते सेकंड प्रॉब्लेम तोच आहे ते सॉल्व करताना खूप आन्सरचे व्हेरिएशन्स यायला लागलेत ते ब्रॅकेटमुळे खूप प्रॉब्लेम येतोय सॉल्व करताना
ब्रॅकेट हा म्हणताय ना नाइन्थ कॉलम.
नाही तो नाही सर YN स्टार्टिंगला जेव्हा कॅल्क्युलेट करायचं आहे ना आपण काल आपण जो प्रॉब्लेम सॉल्व केला त्यात Q इज इक्वल टू AV घेऊन ते मॅनिंगचा फॉर्म्युला घेतला हा ब्रॅकेट नाही स्टार्टिंगला एकदम एरिया आपण पेरिमीटर ना तो ब्रॅकेट YN ची व्हॅल्यू कॅल्क्युलेट
आपण नॉर्मल डेप्थची व्हॅल्यू कॅल्क्युलेट करायला.
हा नॉर्मल डेप्थची व्हॅल्यू कॅल्क्युलेट करायला
आपण हा फॉर्म्युला यूज केला होता Q इज इक्वल टू A इंटू V. ओके. V म्हणजे काय मॅनिंग्स फॉर्म्युला A इंटू 1/n R raised to 2/3 S raised to half. ओके. हा फॉर्म्युला यूज केला होता त्यात आपलं डिस्चार्ज गिवन होतं N गिवन होतं AS गिवन होतं आणि B गिवन होतं बेस विड्थ. फक्त एक अननोन होतं तो होता Y. राईट.
Y. येस सर.
येस. मग इथं आन्सर प्रॉब्लेम काय तो आन्सर मध्ये
हा R raised to 2/3 चा जो ब्रॅकेट तो BY अपॉन B प्लस 2Y raised to 2/3 मग ते सॉल्व करताना ना आन्सर्स मध्ये खूप डिफरन्स यायला लागला कालचं जे आपण क्लासमध्ये आन्सर सॉल्व केला ते आणि आमचं आन्सर खूप डिफरन्स यायला लागले म्हणजे
तुमचं डेप किती यायला लागले तुमचे डेप तुमचं YN किती यायला लागले
सर माझं तर 2.23 समथिंग येत होतं आणि आपलं 2.7 आलं होतं.
ठीक आहे ते 2.7 बरोबर असेल ते सांगता येत ना ते पण
एक्चुअली वो 2.7 सही नहीं है उसको 3.7 रहना चाहिए.
यस सर 3.7 आया
कैलसी में डायरेक्ट आता सर ये आंसर 3.33 ऐसा कुछ तो आता सर.
आणि ट्रायल आणि एरर मेथडनी पण केला तरी ते LHS RHS इक्वल येत नाहीये 2.7 ला.
सर 3.7 को ट्रायल एंड एरर मेथड इक्वल आ रहा है.
ओके. और 3.7
तो सर ये जो एससी की जो 9th कॉलम है ना सर वो 10⁻³ में आंसर आता सर.
हाँ सर काल चुकलंय ते आपलं.
आंसर ना सर माइनस में आता सर. हो सर.
कालचा प्रॉब्लेम सर
ठीक आहे
सर सब इंटू करे थे सर तो आंसर पॉइंट में आ रहा था स्क्वायर करने के बाद 10⁻³ में आंसर आता.
10⁻³ पावर येते सर सगळं.
ओके. ठीक है
फिर
ठीक
जब एवरेज करते ना सर, एवरेज करने के बाद माइनस में आना सर आंसर।
है। एवरेज माइनस में कैसा आएगा?
हाँ सर, 10⁻³ माइनस करे ना सर, तो एवरेज करे ना दोनों का 10th कॉलम में माइनस में आंसर आ रहा सर वो।
10 माइनस आ रहा है या आंसर माइनस में आ रहा?
हो सर,
आंसर
आंसर
माइनस।
आंसर 9th कॉलम का आंसर प्लस में है सर, जब एवरेज करते हैं ना 10th कॉलम में, तो आंसर जब माइनस में आ रहा सर, तो आगे
एवरेज माइनस में कैसा आएगा ऐसा?
सर आंसर।
पॉइंट नंबर 11 सर.
हाउ
मध्ये
कॅन?
ना सर, पण पॉइंट मध्ये येत आहे 0.000 असं येत आहे,
हा चालतंय ना मग.
पण मायनस येईना.
मायनस आलंच नाही पाहिजे. तुम्हाला कोण म्हटलं मायनस मध्ये आन्सर आलं पाहिजे?
नाही सर, मायनस आलं नाही,
हा
प्लसच आलं.
नाही मायनस आन्सर आलंच नाही पाहिजे कुठंच इथं. कुठलाच आन्सर इथं मायनस मध्ये नसलं पाहिजे. ओके.
ओके सर.
प्रॉबेबली जो आर जेव्हा तुम्ही सॉल्व्ह करता, बी ची व्हॅल्यू गिव्हन आहे, फक्त वाय अननोन आहे, तर तुम्हाला शेवटी बहुतेक क्वाड्रॅटिक इक्वेशन सॉल्व्ह करायला लागत असेल वाय, बरोबर का?
हो सर.
यस सर.
ओके. I'll do one thing. I will post the after everyone submits. I'll post one solution to the numerical by solving it. Okay.
येस सर.
Sir, in trapezoidal only the area and perimeter we have to change as compared to the rectangle one.
Yes. In that you have been given the y. I forgot to give you the value of side slope, that is m. Okay. So using the side slope and the base width, you can find out the area b plus my into y. Okay. And here it is something like b plus 2y square root of m square plus 1 something. Okay. So only here the formula will change. Okay, it will come as the formula for trapezoidal area and perimeter. After that, the remaining steps will all be the same. Understood?
Sir, actually, I referred a YouTube video, and our in the ninth column, they took the formula as 9 into v raised to square divided by r raised to 2/3. They didn't did it the whole square.
They did not take the whole square. No, but that is not correct, because as the formula goes, v is equal to 1 upon n r raised to 2/3 s raised to half. Okay, this is the formula for Manning's coefficient. Now, if you take everything on one side, okay, or if you take s raised to half on one side, you will get nv upon r raised to 2/3, correct? And if you square both the sides, you will get s is equal to nv upon r raised to 2/3 whole bracket square. Okay. So the formula that we have taken is correct. Okay. YouTube वरचा व्हिडिओ चुकला असेल, असं नसतं की YouTube वरचे सगळे व्हिडिओज बरोबर असतात. ओके. ते काय असतात, मोस्ट ऑफ द टाइम ऑन YouTube what happens is a person who has done general civil engineering, for the purpose of making the videos, they make videos even on structure, they make even on transportation. The same person makes the videos on hydraulics. Okay. So it is not possible that he has gone into detail of the every formula, okay, whether it is correct or not. So when you have a doubt, please do not refer the YouTube videos available. Please refer the textbook that I have given to you. or any other textbook. Okay, any standard textbook that you have to refer that. Please keep that in mind. Any other question, or should we proceed?
Yes, sir.
Okay. Is the slide of rapidly varied flow visible to all?
Yes, sir.
Yes, sir.
Okay. So today we will be starting with the new topic of the third unit, which is the rapidly varied flow. Okay, if you see the syllabus, we have completed the gradually varied flow part. Okay, we have studied the definition of gradually varied flow. We have studied the dynamic equation of gradually varied flow. In it, we have studied the assumptions and we have derived the equation. Then we have done the classification of channel slopes. Okay, whether the slope is mild slope channel, steep slope channel, critical slope channel, horizontal bed, or adverse slope channel. Then we have done classification of gradually varied flow profiles, M1, M2, M3 curves, C1, C3 curve, S1, S2, S3 curve, H2, H3 curve. We have studied the different curves. Then we have studied the different examples of the curve. Okay. आपण examples बघितले होते, flow over the weir, flow over a sluice gate, etc. Then we have studied the direct step method of computation of gradually varied flow profile. Now today we'll be starting with the rapidly varied flow. Now under this heading of rapidly varied flow, we are going to study the definition of rapidly varied flow. What are the different examples of rapidly varied flow? There is only one main example of rapidly varied flow, and that is your hydraulic jump. So we are going to study about the phenomenon of hydraulic jump, and then moving further, in the part of hydraulic jump, we are going to study the relation of conjugate depth. We will study what is meant by conjugate depth. Okay, what are the parameters for the hydraulic jump to occur? What are the uses of hydraulic jump, and what are the different types of hydraulic jump? Okay, so let's begin. The hydraulic varied flow, it is represented by its short form, that is RVF. So in further slides, if it is referred by RVF, it means the rapidly varied flow. Now first, let us study what will be the lecture outcomes of today's lectures. So after the completion of today's lecture, students will be able to understand what is a rapidly varied flow, and you will be able to identify a rapidly varied flow. You will be able to differentiate a rapidly varied flow from a gradually varied flow. Then next, students will be able to understand what is a hydraulic jump. Okay. So for that understanding, today I'm going to show you a video from Easy Engineering. Easy Engineering is a channel on YouTube. Okay, it is one of the best channel for hydraulics and water resource engineering, as well as transportation and geotechnical engineering. You can just search Easy Engineering on the YouTube app. So let us start. I hope you're all now familiar with what will be the outcomes of this lecture. Let's begin. So what is a rapidly varied flow? For that, let us just briefly revise what is a gradually varied flow. So what is a gradually varied flow? Gradually varied flow is one in which the change in depth, okay, the change in depth takes place over a very long distance gradually. That means in a gradually varied flow, which is a non-uniform flow, the change in depth is very gradual. It is going to take place very gradually over a very long distance. Okay, that means to go from a depth of 2 meter up to 3 meter, it is going to take a very long distance. Okay, that change is going to take place over a very long distance. But what is rapidly varied flow? In the rapidly varied flow, the change in depth takes place over a very short distance rapidly. So most commonly, the change in depth takes place over a single section. Okay, single section, instead of single section, the change in depth takes place over a very short distance as compared to the gradually varied flow. So let us see the definition. So rapidly varied flow occurs when there is a significant change in water depth over a short distance. Okay. So as you can see in the image that I'm showing, and as you're going to see in the video that I'm going to show, the change in depth takes place over a very short distance. Okay, let this be the distance L. So for a rapidly varied flow, you can observe with your naked eye the sudden change in depth. Whereas in the gradually varied flow, you could not identify the change in depth because the change in depth was very smooth. It was taking place over a very long distance. Okay, तर तुमच्या नेकेड आयला काय वाटतं की हा फ्लो युनिफॉर्मच आहे. त्याच्यामुळं जर तुम्हाला आठवलं डायनॅमिक इक्वेशन ऑफ ग्रॅज्युअली वेरिड फ्लो मध्ये आपण जे अझम्पशन्स केले होते त्यातले बऱ्यापैकी अझम्पशन्स आपण असे होते की ते ग्रॅज्युअली वेरिड फ्लोला युनिफॉर्म फ्लो म्हणून कन्सिडर करत होते काही अझम्पशन्स. ओके, this was because for your naked eye the gradually varied flow seems like a uniform flow itself, but still it is a varied flow. But in the case of rapidly varied flow, you can observe with your naked eye the sudden change in depth over a very short distance. So that is the definition of rapidly varied flow. Now rapidly varied flow can be caused due to one or more of the following factors. So what are those factors due to which RVF is caused? It occurs when there is a local disturbance to the balance between gravity and friction. Okay, so for example, okay, your river is flowing now with a normal depth, so I'll consider it is a uniform flow. But if there is a local disturbance, what is an example of a local disturbance? For example, if further there is a waterfall. For example, if there is a waterfall, so what will happen? You can see here there is a sudden change in depth due to the disturbance such as a waterfall. Okay, and you can observe that change in depth with your naked eye. You can see any image of a waterfall, you can see the depth suddenly changing. So this is an example of rapidly varied flow. Okay, similar examples take place at the weir or due to a sudden change in slope. weir जर बघितलं तुम्ही तर weirच्या अपस्ट्रीम साइडला काय मिळतं तुम्हाला ग्रॅज्युअली वेरिड फ्लो. बट इफ someone has unmuted himself. Okay, so as you can observe, at the upstream side of the weir, it is a gradually varied flow. But if we consider that the length, instead of length, let the top width or the crest of the weir be very long. So what will happen? You can easily watch here the change in depth, sudden change in depth at the top of the weir. Okay, so here the depth is changing over a very short distance. So this is also an example of rapidly varied flow. The second reason or the second factor which causes rapidly varied flow is the mismatch between the depths imposed by upstream and downstream conditions. Okay, so and that example is the hydraulic jump. Now, as I have told to you, rapidly varied flow, okay, takes place on the downstream side of a weir. Hydraulic jump always takes place at the downstream side of a weir. तर काय होतं, weir मधनं पाणी पडणार आहे. It is going to have a very short depth. Okay, as it is going to have a very short depth at the downstream side of the weir, it is a supercritical flow because the velocity is high, and suddenly what will happen? This supercritical flow is going to get converted into subcritical flow at the hydraulic jump. Now, as I have told to you 2 lectures back, okay, when we were studying the examples of the different gradually varied flow profiles, the supercritical flow takes place due to the upstream conditions. Upstream condition कुठला या केस मध्ये? Construction of a weir. So due to the construction of the weir, the water is falling from a greater height, so it is having a very high velocity, and due to this upstream condition, the supercritical flow has occurred. But as opposed to that, the subcritical flow occurs due to the downstream conditions. Okay, it occurs due to the downstream condition. कारण की काय होणार आहे, पुढे जाऊन तुमचं डेप्थ नॉर्मल होणार आहे रिव्हरची डेप्थ काय होणार आहे, नंतर एकदा वियरला पास करून थोडे डिस्टन्स पुढे गेलं तर युअर रिव्हर इज गोइंग टू रिटर्न टू इट्स नॉर्मल डेप्थ and it is going to flow as a uniform flow. So due to this downstream condition, okay, the subcritical flow takes place. So due to this mismatch between the upstream condition and downstream conditions, the hydraulic jump takes place, which is an example of rapidly varied flow. I hope everyone is understanding this.
Yes, sir.
So these are the 2 reasons due to which the rapidly varied flow is going to take place. Now, any question regarding this slide? Any doubt? Yes, any doubt? Okay, so let us proceed about studying the hydraulic jump, because rapidly in the part of rapidly varied flow, okay, the most important point is the point of hydraulic jump from the standpoint of us as civil engineers or hydraulic engineers. So let me first share the video of what is a hydraulic jump with you. Just you have to tell me whether the audio and the video is visible to you. Wait.
Control
Okay.
Of water is one of the fundamental objectives of.
So was the audio proper on that one?
Yes, sir. Yes, sir.
Okay. I'll start from the beginning.
Controlling the flow of water is one of the fundamental objectives of modern infrastructure, from flooding rivers to irrigation canals, stormwater drainage facilities to aqueducts, and even the spillways of dams. So engineers need to be able to predict how water will behave in order to design structures that manage or control it. And fluids don't always behave the way you'd expect. Hey, I'm Grady, and this is Practical Engineering. On today's episode, we're talking about one of the most interesting phenomena in open channel flow, the hydraulic jump. This video is sponsored by NordVPN. Feel safe online, anywhere, anytime. More on that later. Fluid dynamics might sound as complicated as rocket science, but unlike rockets, you probably already have some intuitions about how water flows. The study of how water with a free surface behaves, that is, not confined within a pipe, is known as open channel hydraulics. This field is especially useful in civil engineering, where structures can't usually be tested at scale. We can't build a dam, cause a flood to see how well the spillway works, and then rebuild it if the performance isn't up to standards. Instead, engineers need to be able to predict how well hydraulic structures will perform before they're ever constructed. This is the definition of engineering: to take theoretical knowledge of science and physics, in this case fluid dynamics, and apply that information to make decisions about the real world. One of the most important parameters in fluid dynamics is velocity, or how quickly the water flows. Sometimes velocity is a good thing, like when you're trying to move a lot of water quickly, for example in a flood. Sometimes velocity is a bad thing, like if you're trying to avoid erosion. Either way, it's almost always a key criterion when designing hydraulic structures. But the velocity of flow isn't the only velocity that's important in fluid dynamics. We also care about the velocity of waves, or how quickly pressure disturbances in a fluid can travel. If the flow velocity is exactly equal to the wave speed, we call the flow critical, but it's more likely that these two velocities are different. Slow, tranquil flow conditions are called subcritical. In this case, the wave speed is faster than the flow velocity. You can see that the waves can travel against the flow direction. Because of this, the depth is controlled by downstream conditions. You can see that anything I do upstream isn't changing the depth of this flow. Fast-moving flow is called supercritical. In this case, the flow velocity is faster than the wave speed. You can see that the waves aren't able to propagate upstream. Supercritical flow is controlled on the upstream side, so nothing I do downstream affects the depth of the supercritical flow above. A flow profile can naturally transition from subcritical to supercritical, that is, from slow to fast. For example, if a channel changes to a steeper slope or a cliff, many types of flow measurement devices rely on forcing a flow to transition from sub to supercritical because there will be a unique relationship between the flow rate and the depth for a given geometry. Maybe we'll talk more about flow measurement in a future video. But when flow transitions the other direction, when a fast-moving supercritical flow transitions to a more tranquil subcritical condition, something much more interesting happens: a hydraulic jump. The classic demonstration of a hydraulic jump can be seen at the bottom of your sink. Open the faucet and watch how the flow behaves. You can see the fast-moving flow right as the stream hits the sink and the abrupt transition of the hydraulic jump to a slower-moving flow. But the sink demo isn't the best example because it happens due to surface tension, not gravity. Plus it's kind of boring, so I built this flume in my garage to give you a better look at the hydraulics. If I open the upstream gate by just a little bit, I can create supercritical flow in the flume. Now, if I obstruct the area downstream, I can force the flow to transition into subcritical. Right where the flow transitions, you can clearly see the hydraulic jump. This phenomenon happens naturally in certain locations. Steep mountain streams often have supercritical flow, crashing into rocks and changing slopes, creating whitewater and turbulence, and the occasional hydraulic jump. Also, a tidal bore occurs when an incoming tide forms a wave that travels upstream against a river. These events only occur in a few places across the world, but it's fascinating if you get to see it in person. In many cases, the bore travels as a moving hydraulic jump, similar to what you see here in my flume. But jumps aren't just natural phenomena, they're important in hydraulic structures as well, especially for energy dissipation. A major part of the job of a civil engineer working in the field of hydraulics is designing against erosion from the flow of water. When we try to control the flow of water, that often leads to the potential of having fast-moving, erosive conditions. For example, when we put water in a culvert rather than allowing it to flow over a roadway, it can pick up speed in the pipe. When we line a ditch or creek with concrete, the smoothness speeds up the flow compared to natural conditions. And when we make releases from a reservoir behind a dam into a spillway, the water can come roaring down at extremely high velocities. This supercritical flow can cause erosion and eventually lead to failure of the structure. So most hydraulic structures will be equipped with some form of energy dissipator on the downstream end to reduce the velocity of flow and protect against erosion. There are all kinds of hydraulic energy dissipators, but for large structures like spillways, the most common types rely on the formation of a hydraulic jump. Because a hydraulic jump causes so much turbulence, it's able to effectively dissipate hydraulic energy as heat. So many energy dissipators, also called stilling basins, are designed to force a hydraulic jump to occur. There are many types of stilling basins, but most use different combinations of blocks, insills, and overall geometry to control how the hydraulic jump forms. The turbulence stays within the stilling basin with the objective of having smooth, tranquil, subcritical flow leaving downstream, minimizing the potential for erosion which would otherwise threaten the integrity of the structure. Hydraulic jumps don't just serve utilitarian purposes. Recreational whitewater courses can be found across the world, and many of these courses make use of hydraulic jumps as artificial rapids. In fact, many kayak parks started out as obsolete dams in need of removal, a perfect opportunity for replacement with something more beneficial to the community and the environment. Freestyle kayaking, also known as playboating, involves performing tricks in a single spot. Playboaters use natural and artificial hydraulic jumps to stay in one spot. I've never tried this myself, but it looks like a lot of fun. Next time you see water flowing in an open channel, try to identify if it's sub or supercritical, and keep your eye out for hydraulic jumps. Thanks to NordVPN for sponsoring this video. I'm really happy to share the sponsor.
Okay, did everyone see the video?
Yes, sir.
Okay. So I'm just sharing the screen now. Okay, so as explained in the video, you can I'll put the share link of the video in our group after the lecture. You can watch that video. You can also watch the other videos by that man in the channel. Sorry, I said it is easy engineering. The name of the channel is practical engineering. Okay. So there are very good videos on transportation engineering, water resource engineering, as well as on soil mechanics. Okay. Now, as said, now why is the study of hydraulic jump important for us as civil engineers? That means, why are we studying the hydraulic jump? Now, hydraulic jump for us as part of study is important in the design of hydraulic structures. Now, what are the hydraulic structures? The hydraulic structures can be dam, weirs, barrages, okay, bridges, canals, okay, then bank protection structures, etc. Bank protection structure म्हणजे काय? रिव्हरच्या बँक्स वरती आपण जे वॉल्स कन्स्ट्रक्ट करतो, ओके, सो दॅट द रिव्हर वॉटर डज नॉट इरोड द बँक्स. They are known as the bank protection structure. So for construction of any hydraulic structure in an open channel, the study of hydraulic jump is very important. Okay, and the importance of hydraulic jump is twofold. Okay, First of all, hydraulic jump is dangerous for, yes, the hydraulic jump is dangerous for the hydraulic structure. And so measures have to be taken to protect against the hydraulic jump. Second, hydraulic jump is sometimes beneficial to us as civil engineers. So in that case, we have to, okay, artificially create an hydraulic jump. As hydraulic engineers or civil engineers, तुम्हाला एकतर हायड्रॉलिक जंप अकर होते त्याच्यापासून तरी वाचवायचं आहे तुमच्या स्ट्रक्चरला, किंवा ओके तुम्हाला आर्टिफिशियली हायड्रॉलिक जंप काही ठिकाणी तुम्हाला क्रिएट करायला लागणार आहे. आय होप यू आर अंडरस्टँडिंग. सो in both the cases, the study of what is an hydraulic jump is very important to us. Now, as with regards to the first case, okay, there is a weir constructed. Okay, sir. There is a weir constructed on the river. Someone please unmute himself. Sorry, someone please mute himself. B25. Okay. Now what will happen? The water, when it flows through a river, okay, first it will be supercritical flow, then at the hydraulic jump that supercritical flow is going to get converted to subcritical flow. But at this sections, what is going to happen? Hydraulic jump is going to occur, and there is going to be violent changes in energy, violent losses in energy, and due to this, okay, आणि इथं जो फ्लो असणारा हायड्रॉलिक जंप वरती तो एक प्रकारचा टर्ब्युलंट फ्लो असतो. टर्ब्युलंट फ्लोचं एक्झाम्पल कुठलं द्यायचं म्हटलं की तुमच्या वॉशिंग मशीन मध्ये जेव्हा पाणी फिरत असतं, ओके, टॉप लोडचे जे वॉशिंग मशीन्स असतात त्याचे पाणी फिरत असतं, त्याप्रमाणे इथं काय होतं, देर आर एडीज फॉर्म, ओके, एडीज अँड व्हर्लपूल्स फॉर्म at the site of the hydraulic jump, which results in loss of large amount of energy. It is also very violent and turbulent, due to which there is erosion of the soil structure beneath the flow. हा जो सॉइल स्ट्रक्चर आहे इकडं त्याचं काय होणार आहे, इरोजन व्हायला स्टार्ट होणार आहे. आणि एकदा इथं इरोजन स्टार्ट झालं तर काय होणार आहे, दॅट इरोजन इज गोइंग टू ट्रॅव्हल अपस्ट्रीम. ओके, त्या इरोजनचा जो एरिया असणार आहे तो थोडं थोडं करून काय होणार आहे, मोठं होत जाणार आहे, until it starts affecting the toe of the weir. आता हा जो weir आहे त्याच्या अपस्ट्रीम पार्टला, अपस्ट्रीम बॉटम पार्टला आपण हिल म्हणतो, वी कॉल इट ॲज हिल, आणि या पार्टला आपण काय म्हणतो, वी कॉल इट ॲज टो. सो द हायड्रॉलिक जंप इज गोइंग टू स्टार्ट इरोडिंग द सॉइल until it reaches the toe, and when it reaches the toe and when it starts eroding that part of the toe, what is going to happen, your structure is going to get destabilized, and in the further future it is going to fail. Now in this case, this is the first case. In this case, what we have to do is we have to protect our structure that we as civil engineers have built against failure. So the most common thing that we can do here, there are various number of methods that we are going to study in detail in the water resource engineering part. आपण water resource engineering मध्ये डिटेल मध्ये स्टडी करणार आहे, which are the different methods for control of hydraulic jump. But one simple method that I'm going to tell you is, okay, instead of the soil bed which is going to get eroded, what we are going to do, we are going to create a bed of concrete here. We are going to create a bed of concrete on the downstream side of the weir, so that when the hydraulic jump takes place here, the concrete bed will act as a protection for the soil bed below it. Okay, so there is no erosion, and your structure remains intact for a very long period of years. Now 68 students have joined. Let me just take the attendance. I'll just write down the attendance. Just wait for 2 minutes. I think Wasim sir is not there today. Yes, until I take the attendance, is there any question regarding the video that I showed or regarding the explanation? It should be a free discussion. Anyone can ask.
तर कॉन्क्रीट डॅमेज होऊ शकतं ना?
Concrete damage होऊ शकतो की?
मग एकदा डॅमेज झालं की परत एकदा हे करायचं कॉन्क्रीट?
नाही बघ, सॉइल स्ट्रक्चर आणि कॉन्क्रीट स्ट्रक्चर मध्ये बघ जरा डिफरन्स आहे. सॉइल कशी असती, जरा लूज असती, बरोबर?
येस.
It can easily get eroded. So concrete तेवढं लवकर erode होणार आहे का नाही? It is going to take a very long time for the concrete to get eroded. So that is not a particular problem. Okay, the concrete can almost it can work up till the total life of the weir. जेवढी weir ची life आहे त्या total life पर्यंत concrete चालू शकतो. Even if the concrete gets eroded, okay, what we can do is we can do patchwork there. आपल्याला पूर्ण बेड बदलायला लागणार नाही, फक्त जिथं हायड्रॉलिक जम्प अकर होतोय, ओके, एक पर्टिक्युलर सेक्शनला, तिथंच आपल्याला काय करायला लागणार आहे, कॉन्क्रीटचं पॅचवर्क करायला लागणार आहे, जरी करायला लागलं तर. ओके, अँड इट इज फार चीपर देन हॅव्हिंग टू कन्स्ट्रक्ट अ न्यू इयर.
ओके सर.
ओके, एनीवन एल्स? We are going to take the second point in which we will be studying about how hydraulic jump can be essential, how hydraulic jump can be beneficial. So can anyone tell me any one area in which hydraulic jump can be beneficial? आपण हायड्रॉलिक जंपला कुठे यूज करू शकतो?
बॉटम ऑफ
डॅम.
नाही म्हणजे ते मग यूज काय त्याचा? बॉटम ऑफ द डॅमला तर अकर होणारच आहे, ते तुम्हाला करायला लागणार नाही वेगळं.
व्हेलॉसिटी कंट्रोल करतो.
वेलॉसिटी कंट्रोल करतो. व्हेरी गुड. Any other? Just by common sense, can you find out any other use that you can have for hydraulic jump? अशा गोष्टीत स्टुडंट्स डोकं खूप चाललं पाहिजे, हे कुठे यूज करू शकतोय मी?
फ्लो कंट्रोल करू शकतो सर बऱ्यापैकी.
हा, तेच वेलॉसिटी कंट्रोल
कमी
म्हणजे
करण्यासाठी.
हॉरिझॉन्टल फ्लोर कॅनल.
येस, व्हॉट?
Horizontal floor of canal, sir.
I didn't get it. What you are trying to say?
Sir, supercritical flow hydraulic jump subcritical greater than डेप्थ लेस पण हो सकते सर, ग्रेटर भी हो सकते सर, सुपर क्रिटिकल एंड सब क्रिटिकल सर.
So you are trying to say to change the flow from subcritical to supercritical.
Yes sir.
Okay. Okay, that can be one use.
Energy dissipation.
Yes, yes, that is velocity हे करणं, velocity कमी करणं, flow control करणं, everything comes under energy dissipation, and we are going to study the concept of energy dissipation in the coming lectures. Okay, any common use that you can tell? Okay, so just search for the uses of hydraulic jump. One of the use I'm going to tell you where hydraulic jump can be beneficial. Just as the 2-3 students said, for lowering the velocity or for controlling the flow or for energy dissipation. So if the supercritical flow takes place for a very long length of the channel, supercritical flow is a flow with a very high velocity and with a very high kinetic energy. Now, due to that, what happens? This flow poses a greater danger for the bed of the channel as well as the side bank of the channel also. हे काय करू शकतं, साइडचे बँक सुद्धा इरोड करू शकतो तुमचं सुपर क्रिटिकल फ्लो, बॉटमचं बेड सुद्धा इरोड करू शकतो. इवन जे ट्रीज वगैरे असतात बँक्स ऍट द साइड ऑफ द चॅनल, ओके, इट कॅन इवन डिस्ट्रॉय दोज super due to the supercritical flow. So our work as engineers is, what do? We have to decrease the velocity. How can we decrease the velocity? By artificially creating a hydraulic jump where the subcritical flow will change to, where the supercritical flow will change to subcritical flow. आणि एकदा काय फ्लो तुमचं सबक्रिटिकल झाला तर काय होतं, सबक्रिटिकल फ्लो हॅज अ व्हेरी लो वेलॉसिटी. ओके, it travels in a very tranquil, very smooth manner, not destroying anything in its path. Okay, and for that purpose we construct a number of structures such as dikes. Dikes म्हणजे काय असतात, एक जर तुम्ही वियर बघितला असेल बंधारा, तर त्याच्याप्रमाणे छोटे छोटे काय असतात, या प्रकारे डाइक्स आपण कन्स्ट्रक्ट करतो. इथं काय होतं मग, सुपरक्रिटिकल फ्लो when it comes in contact, what is going to happen when it passes through these dikes? A hydraulic jump is going to be created on the downstream side of the dike. Okay, and the supercritical flow is going to get changed into subcritical flow, thereby lowering the velocity as well as controlling the flow. Okay, so let us study the hydraulic jump in detail. In an open channel, when rapidly flowing stream abruptly changes to slowly flowing stream, this is important. When rapidly flowing water abruptly changes to slowly flowing water, a distinct rise or jump in the elevation of the liquid surface takes place, and this phenomenon is known as the hydraulic jump. Okay, and it is analogous to the shock wave in a compressible fluids. Now we are not going to study about this, it will just help in confusing everybody. So in an open channel, when rapidly flowing stream abruptly changes to slowly flowing stream, a distinct rise or jump in the elevation of the liquid surface takes place, and the phenomenon is known as the hydraulic jump. Okay, now there are some important points related to hydraulic jump that everyone should know. The hydraulic jump converts kinetic energy of the stream rapidly flowing into potential energy. Okay, now this is the hydraulic jump. Now supercritical flow मध्ये काय जास्त आहे, वेलॉसिटी जास्त आहे. वेलॉसिटी जास्त आहे म्हटल्यावर कायनेटिक एनर्जी जास्त आहे. आता इथं जी एनर्जी डिसिपेशन होणार आहे, okay, some energy is going to get destroyed, but some energy is going to get converted into potential energy. आता पोटेन्शियल एनर्जी डिपेंड्स अपॉन द हाईट ऑफ एनी बॉडी. ओके, greater the height of the body, greater is the potential energy. तर increase in height, what does it represent? It represents that some amount of kinetic energy has been converted into potential energy. ओके, आता इथं जो हायड्रॉलिक जंप होतो, हायड्रॉलिक जंप म्हणजे काय आहे जर सिंपल भाषेत ओके एक्सप्लेन करायचे, ओके, द प्रोसेस फ्रॉम वेअर the supercritical flow has started changing up to the point where the supercritical flow has changed to subcritical flow. That total okay distance is nothing but your hydraulic jump. Just a reminder for everyone. Okay, so the first important point is hydraulic jump converts kinetic energy into potential energy. Now due to this there is a loss of kinetic energy. Okay, now due to this loss of kinetic energy there is dissipation of energy. At the place where hydraulic jump occurs, rollers of turbulent water, that is aiding turbulences are formed, which causes the dissipation of energy. Okay, so when the hydraulic jump is taking place, I hope you have seen in the video what happens. At the place of hydraulic jump, the waves are trying to travel backwards against the direction of the flow. तुम्ही YouTube वरती सुद्धा जाऊन हा व्हिडिओ परत एकदा बघू शकता. Any video of hydraulic jump, you will observe that at the hydraulic jump, a wave-like structure is formed which is trying to travel upstream against the direction of the flow. Now these are known as the rollers of turbulent water, or the phenomenon is known as eddying turbulence. And due to this, what happens is there is a loss of, or there is a dissipation of energy. Dissipation म्हणजेच काय? Loss of energy. A hydraulic jump occurs in practice at the toe of spillways or below a sluice gate where the velocity is very high, as I have already told you. एखाद्या हायड्रॉलिक स्ट्रक्चरच्या डाउनस्ट्रीम साइडला नॉर्मली काय होणार आहे, तुमचा हायड्रॉलिक जंप अकर होणार आहे. हायड्रॉलिक जंप, okay, where the velocity is very high. And lastly, the hydraulic jump is also known as a standing wave because it is in essence a wave which is stationary at one place. So the hydraulic jump, it is also known by its other name, that is a standing wave. जसं त्या व्हिडिओ मध्ये लास्ट मध्ये नरेटरनी सांगितलं होतं की कायाकिंग एक ऍक्टिव्हिटी आहे. इट इज अ टाइप ऑफ एन ऍडव्हेंचरस स्पोर्ट विच पीपल डू. सो what is done is artificial hydraulic jump is created, which is nothing but an essentially a standing wave, so that and the kayaks or the boats, they are placed on this standing wave. Okay, so these are some important points of hydraulic jump. Any question? Any questions? This is an image of hydraulic jump. This is a diagram that we are going to use in order to derive some important physical properties of the hydraulic jump. आता आपल्याला physical properties of hydraulic jump मध्ये काय काय लागणार आहे? एक तर आहे height of the hydraulic jump. आता height of the hydraulic jump काय असणार आहे? On the upstream side, supercritical flow is there. म्हणजे सेक्शन 1 वरती supercritical flow आहे. हायड्रॉलिक जंप झाले आणि या सुपरक्रिटिकल फ्लो कन्वर्ट झाले सबक्रिटिकल मध्ये. सेक्शन 2 मध्ये जर तुम्ही बघताय तर एक आहे सबक्रिटिकल फ्लो आहे. सो द डिस्टन्स बिटवीन supercritical flow and subcritical flow, or distance between section 1 and section 2, denotes the height of the hydraulic jump. It denotes the height of the hydraulic jump. Next point that we are going to find out is the total length of the hydraulic jump. From section 1 to section 2, hydraulic jump occur व्हायला किती length लागलेली आहे, that we are going to find out, and that is the length of the hydraulic jump. And the third point that we are, and the third characteristic that we are going to find out is the total energy loss or the total head loss between section 1 and section 2. So in the next lecture, what all we are going to find out? We'll find out the height of the hydraulic jump, we'll find out the length of the hydraulic jump, and then we'll find out the total energy loss or head loss that has occurred in the hydraulic jump. Okay. Now, from the next lecture, we are going to find out the height of hydraulic jump. Now, before that, let me just do an analysis of hydraulic jump. Okay, there are some assumptions which are made in the analysis of hydraulic jump, similar to the assumptions that were in the gradually varied flow. So what are the assumptions? Let us see. There are only 4 assumptions, so we'll see one by one. Loss of head due to friction at the walls and channel bed is negligible. Okay. So while we are deriving the different parameters of hydraulic jump, we are going to assume that the loss of head due to friction at the walls and channel bed is negligible. Wall and channel bed म्हणजे काय? For example, हा तुमचा rectangular channel आहे किंवा हा तुमचा trapezoidal channel आहे. So the loss of head due to friction at the walls as well as the bed हे आपण consider करणार नाही. Okay, we are not going to consider the loss of head due to friction at the walls and channel bed. Okay, and why that is important, that I'm going to again tell you while we are deriving the equation. Second assumption is the flow is uniform and the pressure distribution is hydrostatic before and after the jump. Okay, this is important. What assumption we are going to make in hydraulic jump? That the flow is uniform. आता flow uniform म्हणजे काय आहे? Let me just show you the hydraulic jump. थोडं खाली दाखवतो मी. Okay. So this is the hydraulic jump. This is the supercritical flow. And this is the subcritical flow. So what we are going to assume here that, okay, this is section 1. आपला तो diagram मधला section 1, this is the section 2. Now our assumption is that on the upstream side of the section 1, everyone please mute yourselves. Okay, on the upstream side of section 1, this supercritical flow is going to be uniform. And on the downstream side of this section 2, the subcritical flow is also going to be uniform. आता varied flow कुठं occur होतोय hydraulic jump मध्ये? RVF. Hydraulic jump is nothing but an example of rapidly varied flow. पण आपलं assumption काय घेणार आहे आपण, हे महत्वाचं आहे. Please pay attention. On the upstream side of section 1, जिथं supercritical flow आहे, the flow is uniform. And on the downstream side of section 2, where the subcritical flow is taking place, that flow is also uniform. Okay. And second, the pressure distribution is hydrostatic. Hydrostatic म्हणजे काय? जसं आपण static flow कुठं? For example, in a tank or on the upstream side of a dam, आपण कसं assume केलं होतं? the pressure distribution is hydrostatic. That means the pressure is zero at the free surface and pressure increases as we go below, and pressure is maximum at the bottom. That is what we are going to assume at section 1 and section 2. Okay, that the pressure distribution is hydrostatic. Hydrostatic म्हणजे काय? The pressure is zero at the surface of water and the pressure is maximum at the bed. Both at section 1 as well as at section 2. Okay, I'll just rub everything and then let's see the remaining 2 points. The channel is horizontal or it has a very small slope. The weight component in the direction of the flow is neglected. Okay, so basically what we are going to consider on the downstream side of the weir, the channel is having a very small slope. That means it is a very mild slope, and for the mild slope the component in the direction of the flow will be neglected. We are going to neglect the weight of the water which is flowing. It will be acting in the downward direction. Okay, it is going to have 2 components, one in the direction of the flow, one perpendicular to the direction of the flow. Now the component of this weight in the direction of the flow, we are going to neglect it because it is not important for the study of hydraulic jump. It does not affect the hydraulic jump in any way. And the last assumption is that the momentum correction factor beta is unity. Now you just have to remember the last one. I'm not going to go into the details of the last point. Okay, because this is not important for you. ते म्हणण्यापेक्षा तुम्हाला पुढे हायड्रॉलिक्स 2 मध्ये कुठंच लागणार नाहीये. इवन तुमच्या बीई मध्ये, वॉटर रिसोर्स इंजिनिअरिंग मध्ये वगैरे कुठंच लागणार नाहीये. So I'll just skip this last point, but just remember these are the 4 assumptions in the analysis of hydraulic jump. Now in tomorrow's lecture we will be starting with the derivation or the expression of the height of hydraulic jump. आपण derive करणार आहे equation for the height of hydraulic jump. त्याच्या आधी आपण हे assumptions परत एकदा बघणार आहे आणि मग आपण पुढे प्रोसीड करणार आहे. So thank you everyone. Is there any doubt, any question?
No, sir.
No, sir.
Okay, so shall I end the lecture?
Sure, sir.
Yes. Yes. Who is it? Okay, I'm ending the lecture now. Thank you everyone.